Okay, let's aim this camera a little bit better. This video is going to be about slip forms. We just started building them. This drawing is it's in 2 scales. Up here is the drawn in inches, and down here it's just scaled up by 2.54. When you scale up a drawing, the properties tab is set for metric, so these numbers are the dimensions, but they're really big. It changes the size of the numbers over the global drawing. So we're going to go down here to metric, where the dimensions are sized for. This is the 4 panels that make up a corner. And this is an end cap. If you end the wall, you have to seal off the end. Now, the reason we're showing this like this is if anybody wants to duplicate these forms, which will be showed in a walk around video. We've already cut the pieces that bolt together and the phenolic board, and we're in the process of drilling holes. They're marked but not drilled. In any event, a next video or 2 is going to be showing the actual construction, screwing them together, and then we're going to set them up either in the dirty kitchen or probably the septic tank first. The dirty kitchen has the advantage that it's up on a flat piece of concrete. So you can walk freely around and try to figure out how to put these things together in real life, where the septic tank we really need. So we'll probably do the septic tank. Okay, this is stuff to make a corner. Let's see if we have something to show what a corner goes together like. Okay. These are the 4 panels we just looked at. These are just the phenolic boards that are in there. These are the phenolic boards that are in the this side. We made one side red, one side blue, just so we could keep the parts straight. Our paint markers are blue and yellow, so it's really blue and yellow in real life. But when it was drawn up, it was red. The red shows up better. And the other thing is when you select, it goes yellow. So yellow on yellow doesn't read. I don't know why this is sitting down. This is supposed to be off the picture somewhere. Okay, anyway, these are the dimensions of what a corner would be in centimeters when it's assembled. Okay. If on any of the drawings, the way you can tell them apart is the dimension on the overall width. Like if we pick this guy here, I'm looking at one screen and trying to move it on the other screen. It's more confusing than it sounds. Okay, for instance, this is the overall width, left to right, is 112.2477. And if we were looking for a panel on that corner, we would be looking for the width that matches the panels. I think these are pretty much big enough to read. I can bump it up 1, 2 maybe. So those are the dimensions, and anything we show dimensions is copyright free. Do what you want with it. Criticize it. Copy it. I don't care. If you need to write down some numbers or something, you just pause the video and write to your heart's content. Okay, who's the next down here? This one's 131.5923. You'll notice that there's a wider piece of phenolic board up here and none at the bottom. Okay, the bottom one is going to sit, well, we set it on insulation, that foil-backed insulation like you loosen roofs. It seals the form against any imperfections in the ground or in a joining form. Generally, these forms are going to bolt up tight, but if we had some really crooked, like cocoa lumber, and we had gaps, and we could put some of that foam in there and just crush it flat with the bolts. It makes it really easy to strip the forms because there's no cement filling up all the little voids. Now, the reason we have the wide section up here, slip form means you make whatever height you make them. They do grain silos with 2 feet of lift. These are 4 feet of lift. What you do is you take this form, and this bolt hole here, when you slide the form up, the bolts will go through these holes up here. If you put these cross bolts real close to the edge, you haven't got much concrete cover above them, just 7/8 of an inch on center from the edge. So that could break that concrete. By putting them farther down, you won't break that big chunk out of the concrete, but you're losing 5 inches off your height. So 48 inches would become 43 inches. So it's 48 the first lift, 43 or less, and 43 or less on a third one. But the red pieces here are the sides. Like if this was another one of these forms just here, it'd be socked up against this, and these bolt holes line up. The bolt holes are measured. Am I on the screen? Nope, not showing. Let's see here. From this edge where it bolts to the phenolic board to the center of the hole, we just arbitrarily chose 1.5 inches. Could be anything. Could be in the, but they have to all be measured off one edge. That way, when you bolt this phenolic board to the next one, they're all measured from that common line, and the bolts go right through the holes. No problem at all. Let's see, we've done I don't think we've done this one. I'm pretty sure we haven't done this one. Okay, it's on both screens. These are the 4 corner ones, separated. And you'll notice that this is, a piece of lumber is laid flat, and this one's laid flat. This one here, it's perpendicular, but this is going to set on here. You take this notch here, fits that there. So that makes a sharp corner in here and gives you a place to put bolts through it. This one here is going to have a form going up the outside. So this one is laid flat. This bolt goes through that hole. And then there's an end cap if you need it. We're going to plan on doing most everything without end caps, unless we don't have enough forms to make it. We're going too many feet of length. If we're doing 32 linear feet of forms for the dirty kitchen for one side, because they're not connected, there's doors on both ends. So we can do the one side, then flip the forms 180 and do the other side. Anyway, this is the dimensions of the assembled corner. Okay, that's in both pictures. This one's 112.2477. I wonder if the drawing is basically in inches. No, it's not going to do that. It's going to read in what it is. Okay. That's a panel that's 112.2477. This one is a one that got redrawn. Actually, this is not a drawing. This one's a 3D model. We're going to take a look at it assembled in 3D, but when you see these lines going down and crosswise like these things, and then the colors are pretty much a dead giveaway on this drawing. The blue things are spreaders, and these are uprights. They're red, and the background thing is purple. Haven't got it on that one. Normally, there's all the parts are right beside the thing. So this background sheet will have all the holes that these bolts go through. There'll be dimensions on the background sheet, but you have the dimensions right here. The purple, like it's measured off this corner, both down and across. So if you come across 99.5477 and you go down 46.5666, that'll give you that hole. And basically you want to put some nails at these dimensions and those dimensions, and you take a string and you go back and forth through the nails, and that gives you all those intermediate bolt holes pretty accurate, and you only have to lay out about a fourth of them rather than laying out all of them. Let's see. We did that one, did that one, did that one. Okay, there's the dimension on one. This is one of the corner ones. I think I know that number. And this is a drawing. Now this is flat. If you looked at an edge, it would be a single line. But if it's a 3D solid, when you look at it at the edge, you see all the parts. They're basically just made, to extrude is the common term for most CAD programs. You just take a shape and you stretch it straight up. This is RhinoCAD 3D. I use it for airplane fuselages and wings that change airfoil like 3 times from the root to the tip. And this takes all those curves and it uses NURBS curves. And that makes smooth transitions from one section to another. The less sections you use, like you can put 2 or 3 in one place when you have a really abrupt change, but the less sections you lose, let it do the math, the better results you get. It's a lot better at doing things to 27 decimal places than I am to 4. So anyway, I use this program. Works really good. Was not that expensive. No yearly renewal price. Upgrades are free on the series that you use. It's pretty good stuff. But you can change shape when you extrude. You can loft a shape between 2 completely different things. Like a circle and a rectangle, and it'll make a smooth transition. Like a transformer. Most of these drawings will have a undimensioned because all the dimensions are on the same drawing. This shows you how this thing goes together. Notice that this isn't up there someplace. It shows you this actually touches the phenolic board. All the pieces touch the phenolic board. And there's no numbers needed, but that's what that does. Let's get away from corners. We've been doing corners. Okay, this form is a full sheet of phenolic board. It's 8 feet by 4 feet, and what's that? 400 by 800 millimeters. I don't know. Anyways, 4 foot by 8 foot. Oh, let's point out something else here. You notice how this bolt hole is pretty close to the concrete down here. It's only enough that you've got good working room above this spreader. The next one's a little ways up, but the spaces get farther. The pressure on the form is higher at the bottom. Its hydrostatic head is the equivalent in water. But your bolt holes really need to be, for the best strength, you want to get them closer together and then progressively wider. Because of the way we laid these 4 pieces at the same distance apart, that dictated that these 2 and these 3 basically, with good work room, they're all exactly the same centers. But we could close this one up, which was, intentional. But this is a 8 foot form. Dimensions on this left side over here, they're showing where these cross pieces go on the plywood. And the dimensions on the right, that's showing where the through bolts go to connect form to form. So this is an 8 foot. Yeah, with dimensions. This is 121.9200, probably a corner form. Anything less than 4 feet, it's like 14 inches or something, just the way they came out. And they'll be cut after we set the major forms, all but that 14-inch piece. So we'll be set around where the tie rebars comes out of the concrete. And when you get the forms all bolted up and get the rebar that's going to be in the wall tied in there, and then you put the second side on the form. Then we can move them around left, right, front, back, twist them, whatever, to get the best concrete cover on the steel and have all the pieces out of the concrete inside of the form. So there's readjustment done. But if it's under 4 feet, and I know this one is because this thing here is 4 feet to match the phenolic height. This is less, visibly less. It's also 121. This is dead square. That's a half sheet panel. Okay. That was an afterthought thing. This is one it takes to, I think it makes the dirty kitchen form. So there's no filler pieces when using this one because all the big forms just bolt together and there's no piece here to make this like 14 inches wide. The little 14-inch pieces, the way we used to form, were handy because you could beat on those all you want to get it out, and that loosened up everything else. And it was a really small piece of stuff. Sometimes it was just another one of these boards like this, or a piece of phenolic board and some cement bags. We were learning. We used all kinds of stuff. We progressed into a much neater operation. Let's see, is there anything else down below that one? Okay. This is a setup for the septic tank. It shows the outside forms. We're going to make the little filler pieces for here, 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 and there. And that'll give us a rectangular tube of concrete. And once we pour that and take those forms, the next thing you're looking is something that butts into a wall on both ends. That would be this one. If we poured that one, it doesn't butt. So how would you pour this other one? There's no place to put a form on the end of this wall to pour this wall. But if you do it where this one's butted into that wall and butted into this wall, your forms can come straight off. There's nothing in the way. So it would be the perimeter This is the second pour. Again, we go for butt to butt. That would be from here, because that wall is there. So from here to here, that would be pour 3, and pour 4 is butted to here and to there. So there's 4 pours for the first 4 feet of the septic tank. If your septic tank was only 4 feet tall, by the time you pour the 4th one, you're putting the top on it. But we're doing our septic tank about 8 feet of water and 9 or 10 inches of airspace above it. Our vent pipes are 6-inch, so in a 9-inch hole, they ought to get pretty good circulation. In our case, we have our black water and our gray water come in side by side down here. Those can't be under the water, so those determine all the heights. These 2 pipes here, actually the gray water, I think it's 1.5 inches lower than the black water where we ended up with it when it came around the house. Some come around one side of the house, some come around the other side. And by how long the pipe run is, because it's 1 in 48, 1 centimeter down for 48 centimeters along the line, or 1 inch for 48 inches, however you want to look at it. It'd be 1 meter for 48 meters, which is what we did, because we're using the transit on the long runs. That way you set slope on the transit, and whatever number the first end is, if it's like 100 centimeters, then you just have to hold the tape on the pipe and shim it until it reaches 100 from one end to the other. You set your transit up level, and you measure out how far you are from the transit, and you figure out 1/48 of that, and that's how much you have to add to the tape. So once you know that number, you can tilt it. If your transit's on the uphill end, you would be raising up the downhill end until that number showed up on the tape. There's just a tilt adjustment with a hand wheel, like a rifle scope, and you crank it up until you hit that number. When the crosshairs are right on it, no part of a line, no 15 thousandths high or low, then you lock it down and just use it. It's good for the setup until you move it. If you move it, you can reset it, but you're better off to get the transit out when everything's down in the hole. All the couplings and T's and everything's glued together, and all you're doing is setting the height. So what we do is we set the height, we put the shims under it and wedges and stuff, and then we pour concrete. We locked all those graded pipes in concrete. It seals the joints, and and it keeps it from moving. Anyway, this is a setup with 4 forms, and it's got in our case, from the parting line of the 2 forms, the end walls have 24.2677. Underneath of that, this is the dirty kitchen setup. Now, this one has got that shorter than 8-foot piece. If you've made dimensions, that number will show up. And then it's got an 8-foot section and the 4 corners. I didn't realize this wasn't on the screen. I'm looking at the wrong screen and talking about something that's off in the gray. This is where those 2 corner forms would end. This is much bigger than a door. I want it bigger than a door. I'm going to put my door frame in here and just take the 8-foot panel, and whatever bolts are closest to this hole will go in, and then 1 row of bolts will go through wherever they are here. Actually, you could put 2 rows, because these spaces on these corner forms are the same as on the 8-foot form. So you can really crush it down on this end, and the other end will overlap at about a foot, and the bolt hole will be over here somewhere. But that'll let us put our door in, and we'll have piece of wall. You can think of it like a column or a post on either side of the door. And it's it's an exact fit. So we're going to do it that way. This dirty kitchen is $439 by $685. We had a miscommunication about the size of the kitchen, so it ended up like that. This scribble up here, we have measurements for the center lines all those rods are, and that's what the thing looked like. This is what we were doing before the slip forms, and we would have done it if I hadn't seen Texas Filipino make it look so damn easy. And we decided to change. This has got corner columns, 4 corner columns. These are the water pipes inside. These are the vents. These are pipes coming in. Oh, underneath of the vents. That's why you can't see them. Yeah, there we go. Here's the 2 coming in. These are the highest pipes in the tank. Down here, can't really see them. Don't do that. What have I done? Well, they're here sometimes and sometimes they're not. There's one here and there's one over there. Trust me, it's there. It's in this other drawing over here. These are the 4-inch transfer ports. This one is an overflow. That's why we can't see them. This is an overflow. This one keeps the water level from being higher than the inlets. The water from here goes through 2 ports that are out of sight below this wall, I guess. And that makes this and that the same height of water. This one and that one are the same height of water. And then there's a port in this. I told you wrong a minute ago. This one, and that one all have the same height of water. The height is just below the bottom of these inlets, so it doesn't back pressure them. Those transfer ports are down here, farther down in the tank. There's one right there. Okay. So the water goes in, gets to that level, and then there's one up here that is the overflow. Once these 3 tanks are full of water up to the working height, any extra water will come through this and fall into this one. And if we bothered to draw it, there's a hole in this floor. It's a 5-gallon bucket. And that's how it gets into the, that's the lid, much bigger than the tank. That's how it gets into down here below this, which is bigger than the tank, is a gravel bed covered with plastic so the cement and sand didn't get in when we poured this floor. So the overflow goes here. When it backs up and then the water level rises, it's not going into the ground. Then there's discharge ports here to go down the hillside behind the place, and we're going to garden that for sure. It'll be full of water. With the Texas Filipino innovation, this is what our thing looks like now. Let's see if we can get that on this other screen. Okay, you can see here at the top, this is the wider part that gives us leverage when we slip the forms up and put the bottom bolt through the upper hole. This is the the one laid flat, one on edge, and one laid flat and one on edge connections, so that you have a place to put the bolts through. And the separation between these with the bolt flange, that's the phenolic board, that's the form itself. So the bolt will go through this block, the phenolic board, and that block. Same thing over here. You can see there's 4 holes. The bottom ones are closer together and they get wider apart. And they're setting down from the tops for the leverage when you bolt together. Anyway, I've completely stole this idea from somebody else. In fairness, they're different than his. I didn't exactly copy them. Sort of put our own spin on it, you know. But the idea that makes it work came from him, and how to set the bolt holes and things. All that came from him. Thank you. Yeah, this is just this drawing up here. We just scaled up by 2.54 to get it into units that the crew understands. They're not too much for the inches. They try to learn it, but I don't want them to have to pick that up. Their country uses metric. I need to adapt. It's like the language. They don't have to learn English. I need to figure out how to communicate with them with what they use. Okay. Whatever this overly long video turned out to be, and I can't read the clock right now, that's pretty much the how we building these forms. I intend to have a video on actually building them and screwing them together. It probably won't be continuous because we basically cut those cross pieces 2 centimeters long, set a little waste block on one end, butt it up on the other end, and then we cut them to exact fit. Because the lumber, we got some really good lumber. Got it from Patlin Hardware in Maragondon. Well, actually in Sepang. It's a separate town. It's nearer Ternate than Maragondon. But they did a wonderful job. And their hardwood this time, or their we call goodwood this time, turned out to be mahogany. Last we got was Nara. So they not only have